All right, so good morning or good afternoon. We're looking at similar figures. So it's a proportion. We talked a little bit about it last week. We had it on our welcome work either yesterday or Monday, which was Monday in some cases. So similar figures are figures in which sides of the corresponding sides are in proportion to one another. Okay, so that means that their fractions are equivalent. They can be reduced down to the same thing. And the corresponding angles are congruent. The corresponding angles are congruent, okay? That's what you are working on in your IXL this week with your angles or sides that are congruent, meaning the same, okay? Then it says, let me zoom this in just a little bit more. For example, in the triangles below, the blank angles, so that means the corresponding angles, are congruent. The corresponding angles are congruent, and the corresponding sides are in proportion. Therefore, the triangles are similar. Okay? So, what that means is, do you see how these angles are the same? Which means they're congruent, right? But these side lengths are not the same. So if you think about what we did last week, from here to here, if we put our new over our old, we could get a scale factor. Okay? So let's finish these and then we're actually going to do that. So it says the ratio of two corresponding sides of similar triangles is called the scale factor. And that's exactly what we did last week with our dilations. Okay? These triangles are the same, they're just bigger or smaller. So if we find out the scale factor in this particular triangle, our new, apparently it's going the other way, is 18. Our old is 12, which equals, if you divide both of these by 3, you get 6 over 4. You can divide both of them with 6. Divide those both by 2, and you get 3 over 2, or 1.5. So our scale factor is 1.5. So what this is doing at the bottom is proving that. If I take 14 and I multiply it by 1.5, I get 21. If I take 6 and multiply it by 1.5, I get 9. Okay? So this is actually our A. This is our B. And you are going from the small to the big, right? 14 times 1.5, 6 times 1.5, 12 times 1.5. Okay? And that's all that we said down here. So that's all that that's saying. It's a lot of words for what's going on. So let's try the next page. All right. So it's asking us now. It's not telling us, it's asking us now. Are they similar? So if we take the side of AB, that's what this means, AB with a line over it, just as line segment AB, that's 6 over XY, that's 4, and I reduce both of these by 2, I end up with 3 over 2. We're going to see if the next ones give us the same thing. So if I take BC, I have 8 over YZ, 6, divide both of those by 2, and I get 4 over 3. AC is 10, XZ is 8, divide both of those by 2, and you get 5 over 4. So are they similar? Is this, the same? So there is none. These two triangles, while they look similar, are actually not similar. Okay? These two triangles, while they look similar, are not. Okay? They are not similar. They are not similar. Okay? So now what's going to happen is they're going to ask us to find answers for similar triangles. They're going to ask us to find answers for similar triangles. Okay? So if you ever see something like triangle ABC, this little symbol XYZ, that means similar. Okay? That means similar. So let's start with which sides are the same. These don't look the same, right? Kind of makes it harder. But if I rotate this triangle, I would have 18 and 7.2 are the same side, meaning that BC, which is what I don't know, and ZY are the similar sides. So now we are going to do a butterfly. Multiply diagonally, divide by the leftover number. So I'm going to take 18. I'm going to multiply it by 6.8. I'm going to divide that answer by 7.2. So 18 times 6.8 is what? 122 and 4/10. Divide that by 7.2, and what do you get? Okay, so this side right here is 17. Okay,